Hello everyone, it's me Murli. In my previous video, we have seen how to do the data preparation for stores entity in our grocery store use case on Microsoft Fabric. Now, in this video, we'll see how to do data preparation for orders and order line entities. Okay. So here in the previous videos, we have seen how to create some of the entities, right? The product price. We have seen how to create some stores entity. Now what we are going to see here is we'll create some permutations and combinations of different order lines which happens on different stores. Like for example, we are going to create here the permutations and combinations of the products which are sold in the different stores between the date range of 2019 0101 to 2023 0529, which means nearly some 5 years worth of roughly around 4.5 years worth of data. Here I have taken some data set from product price. In this internal query, I am generating some sequence of numbers and I am exploding it. If you run this query on its own, just outside, you'll understand what I was doing there. And then on top of it, I'm doing some transformation to get the store ID values. After that, I'm joining with the stores table, which falls into those store IDs. Means which are store IDs between those min store ID and the max store ID. This is all just I am creating some synthetic data. So for creating that synthetic data, I am using different techniques of generating huge volume data. This generates very big data set, nearly some 2 billion rows if I create something like this. So it will take a lot of time. That's why what I did is I already executed this. It took around 45 minutes, 11 seconds to execute. After it executed, I have seen how much is the row count. It has come to around 2.5 billion rows. This is a very good data set for our big data use case because this is how on the production systems we see the production volumes. And then every month, if you observe, this is just how it is a monthly data. This is on the daily data, right? No, actually this is at the month, the calendar month. So the calendar month, every month I am generating around 46 million rows or 49 million rows or 51 million rows, something like this. This is all randomly generated data set. And then, because this is a table which is created with all these combinations, while I was creating this, I don't know the total number of rows or the total complete data set size. So I executed, I found that this is the big data set and I thought it is a very big data set. Now, let me give some simple example here how I am saying it as a very big data set. If I say here describe detail and if I specify that order line combinations, please bear with me. Okay, now I executed this. We'll come to know how much, actually it is SQL and then describe. So here this provides the output of how many files it has and the totally how many underlying Parquet files it has. And see here all the data is generated in one Parquet file, a very big Parquet file. And see this one, it is around 15 gig of size, the order line combinations. It is underlying, it is 15 gig of size. So What I want to do is, because it is a 2 billion rows with 15 gig, I don't want to use just as it is like this. I want to do it as a partitioned table like how I have shown here. And while creating this partition table, I derived some customer ID as well, some random customer ID based on the order line ID, because this is all we are generating the data, that's the reason. Okay. Now, when you generate this, it shows that so and so customers bought these products in these stores on these different dates, and how much is the quantity they bought of each product. So that's how we are creating this table. And after creating this total table, and see, it took only 3 minutes, because already the data set is available, already the data is created in the order line combinations, the data is in this 15 gig file in the Parquet. Now we have to partition it based on some partition key. What the best practice for any Delta Lake table is, if your table size is less than 1 GB, let us not partition it. If the table size is more than 1 GB, you have to think a way to identify the right partition key and then partition it based on that particular key. What I thought is, because each month it has around this much data set, I thought of actually doing a partitioning on based on the month. Of course, within the month, if you see the size of it, it may not be a 1 gig, but it's okay for our use case. It's a good size for us. So what I did here, I did partition by calendar month. When I did partition by calendar month, it created the table in 3 minutes, 18 seconds. After that, I just did a group by on the calendar month to see if the data is rightly partitioned and rightly created. So I got the same count as what we have seen before. Then I'm just checking how quick the output will be if I use the calendar month partition key. Because when we use the partition key and use the partition key column in a where condition, it uses a optimizer technique called partition pruning. And when I say 2023-0101, it go and get the count only in that particular partition. It will not scan through all the rest of the partitions. So that is the technique called partition pruning in the optimizer. Then I just described it. When I describe it, this is what is the calendar month. It is a partition. And when I say describe detail of this particular partition table, observe this. It has generated 302 files, and the total size has increased to 25 gig. Previously, one file, which is 15 gig, now it has changed to 25 files, 302 files in monthly partitions, and the overall size has come to 25 gig. Now, if we go to just from this table, well, now we got a base data set of the order line combinations partition. And the next step, what I am trying to do now is, I want to create some orders data. So what I am trying to see is get the distinct of the combinations of a person, what all the items, what all the products he purchased in a store in a particular date. I'm combining all these things to make it as a one single order. That's how I'm creating an order table. I'm getting the distinct of those values. That's what I'm trying to do here. So observe this. This is the distinct combination. And always remember, in an order table, we don't see the product data. We see the product data in the order lines table, because one order could contain multiple products. So that's the reason I have taken away the product here and I group them on only these columns to get each order. And I partitioned that particular order table again on the calendar month. Here I have used this technique here to load the data every month by month, because here what I did is I first got the distinct calendar months, and I got the distinct calendar months. I used the transformation called collect, which gives us the list of distinct partitions, and I loop them month by month, which means if I have, let us say, some 40 months of data, it loops 40 times. So thereby, we don't need to run this total query on the big volume to get the orders data. We create the orders data month by month. So in this, with the first loop, the very first time, I'm checking if the table is existing or not. If not, recreate it, yeah. And then I'm inserting the data set. I think I don't need this part. Okay, I'm just inserting the data set. After I, in the first iteration, first I check if the table is not there, I create it. In the next iteration, it will be finding that particular table and keep on inserting the data. So after it inserts the data like this, so I'm just printing it when it is loading the data, and it took around 2 hours 27 minutes 59 seconds, roughly around 2.5 hours to generate the data for these orders full volume. And once after it generated the orders full volume data, I thought the full volume, because it took that much time, some of you may not be using this full volume of data of 2 billions. Then I have just made a smaller version of it for only 3 months of data. So I have put some filter conditions on this just to get only 3 months of data, and exactly the same technique, but it generates only for 3 months. So whoever wants the full volume, you can use the full volume to test all this Microsoft Fabric. If you want to work on just 3 months of data set, you can actually use this 3 months of data set for your testing. Then we got the orders data, something like this. This is how it created. And after that, I want to introduce something called MS Spark Utils. The reason why I want to introduce this one is, this is given by Microsoft to see the underlying files on the Azure Data Lake Gen 2 storage. So I imported that particular library, Notebook Utils, from MS Spark Utils. After that, within that particular orders table, because it has created the orders table here. Here it has created orders table, and then on this orders table I copied the path of this orders table. After I took the copy path, I got this path, and this is the path which I got it from there. And you can see here how it generated all these 5 partitions. Observe this. This is the calendar month, like this. Yeah, and just aggregation again, then now here we got now orders data. Now I want to generate into a file. Here I have taken the example of those 3 months file. This is the function which we have been executing in our previous videos to generate a CSV file. It's a simple function. I have explained about this CSV file in the previous videos. And here I'm using that particular function, generate CSV file, and I'm looping it through those 3 months. So I use the technique, and when I am actually generating the file, I want to generate the file for each day. That's why if you see here, I grouped it on calendar month and the order created date. I'm using this order created date in this loop, o.order created date. So I prefix the file with orders underscore o.order created date. So it has generated the files like this, and it took around 33 minutes for me to generate 3 months worth of data in the CSV files like this. So once after it generated that file, I want to show you how it looks like here in the lakehouse. So in the lakehouse, observe this here. This is the orders under the files, orders. Observe this. It has generated the files like this. Okay. Then I use the very similar techniques again coming to the order lines. So within these order lines, what I did is, again, this is for generating the full volume. The similar techniques, I don't want to go into the detail because it is more repetitive. And then here I want to generate for only 3 months. So this is generated 3 months of data, and I got the order lines with only 3 months. And here I want to generate that order lines data in the CSV files. I did again the same technique, and observe this. What I want to show here is it is running now. I have been working on the very big volumes. At this stage, what happened? My session got disconnected due to some network connection, some Wi-Fi connection or something. And again, I restarted the session. After I restarted the session, when I again started generating this file, not at this stage. Just I restarted the session after this stuff. But before this, what I did is I have been working on big data volumes, and then observe this. What happened when it is generating? It has generated the data for some few records, for few dates like this. After that, it has thrown an error like this. It has thrown an error saying that authentication failed with access token validation failed. And I was a bit surprised, like it is continuously running for every day. It is generating the files, and why it has thrown this error. Then I thought it might be some issue internally because of the communication between my notebook to the cluster, I think. That's the reason I just went here, home, I clicked on stop the session, and again I started the same piece of code again. Because I stopped the session, I copied back again this particular function, because this is a function which I am using it below, and I generated the file. And next time when I generated the file, it has actually generated all the data. And at this time, what happened is my Wi-Fi got disconnected. Even though my Wi-Fi got disconnected, it is continuously generating the files in the background. See, it has generated the files like this. Okay, it has generated all the order lines data. And observe this. This is what I want to show you. Because my Wi-Fi got disconnected and I just refreshed this session, it is not able to change that status. It is still showing as running, but actually it is not running. Okay, it is actually finished here, and it generated all the order lines data. Now we got a very good data set of products, product lines, product categories, customers, stores, orders, and order lines data, which we'll be using in all our subsequent sessions. Okay, stay tuned. We'll catch up again, we'll just wrap it up in this video. Thank you, everyone.